In this video, we will look at two practice problems involving linear equations with one unknown, with fractions in their coefficients. So let's look at the first problem. 5 halves x minus 3 halves is equal to 1/3 x plus 1. So try to work this problem out and then view the solution. As in the previous video, we want to look for the least common multiple. So we have denominators of 2 and 3. And if you write out multiples of 2, not counting 0, you have 2, 4, 6, 8. And for 3, 3, 6, 9, and so on. We're only interested in the least common multiple. So 6 would be that number. So what does this tell us? This shows us that if we were to multiply both sides of this equation by 6, we will end up getting a much simpler equation to work with. So let's do that. So let's take 6 times 5 halves x minus 3 halves. And then let's take 6 times the other side of the equation and see what happens. So 6 times 5 halves would be 15x. 6 times 3 halves would be 9. 6 times 1/3 x would give me 2x. And 6 times 1 is 6. Now this becomes a pretty standard problem. Since you've done a number of these now, we can do two things at once. We could either subtract 2x or 15x. It makes more sense to subtract 2x from both sides, remembering that there are an infinite number of things we're allowed to do. And then we could add 9 to both sides or subtract 6 from both sides. In this case, adding 9 to both sides will keep our numbers positive, but we'll also create numbers on the right-hand side of the equation while having the terms with x, or the term with x on the left. When we add up the left-hand side, 15x minus 2x leaves us with 13x, and the negative 9 plus 9 is 0, and the 2x minus 2x is 0, and the 6 plus the 9 is 15. Now simply divide both sides by 13, and while this isn't a nice fraction, the solution is 15/13, or 1 2/13 if you prefer. Let's consider a second problem. Let's take 2/5 x plus 1/3 equals 1/2 x. Let me make a quick side note here. This hasn't been mentioned in any of the videos. 1/2 x is equivalent to saying x over 2, or x divided by 2. 2/5 of x would be equivalent to 2x divided by 5, or 2 times x divided by 5. So I've written them one way, but you can think of those as in multiple ways. So to solve this problem, if you haven't already done it, pause the video. But to solve this problem, once again, we want to look at the least common multiple. So what are the denominators? The denominators are 5, 3, and 2. So we can write out all of the multiples, or in this case, since they're all prime, we could just consider a few of those. So if we look at 5 and 3, they would have a least common multiple of 15. When you're working with prime numbers, simply multiply them together. 15 would be the least common multiple. But clearly 15 is not a multiple of 2. So let's take 15 times 2 and we get 30. It turns out 30 is the least common multiple. And take cheer, if you get a multiple that's bigger than the least common multiple, you still will get an equation that doesn't involve fractions. So for instance, if I had used 60, I'll simply get an equation that has larger coefficients and numbers than if I multiply everything by 30. So 30 is the least common multiple in this case. These are all prime numbers, so multiplying them together will give me the least common multiple. So let's consider what to do next. Let's take 30 times 2/5 x plus 1/3 is equal to 30 times 1/2 of x. Working that out, 30 times 2/5, you probably want to divide by 5 and then multiply by the 2, so you get 12x, and then 1/3 times 30 is simply 10. 30 times 1/2 is 15x. So we're left with a relatively simple problem. The simplest thing to do at this point would be to subtract 12x from both sides. The left side is left with a 10, and 15 minus 12 would end up giving me 3x. So to finish this, we'll divide both sides by 3 and get a solution that x is 10/3, or 3 1/3 if you prefer. Once again, if you want to make sure this is right, substitute it into the original expression up here and make sure that it actually works.